Okay, so find the derivative given y minus x times sine of y is equal to 3. So the derivative of y is going to be dy over dx. We have product rule, so x is u, sine of y is v. So the derivative of negative x is negative 1, which is why we still have the subtraction, times sine of y plus the derivative of sine of y times negative x. So we have negative x and cosine y times the derivative of y, which is dy over dx. The derivative of 3 is 0. So now we're going to move anything that doesn't have a dy over dx over to the other side. In this case, it is only one thing. So we are going to add sine y to both sides. We have 2 dy over dx's, so we're going to factor that out. When we are reminding ourselves what would be left over, we need to think about it as, what do I multiply dy over dx by to get my other piece here? So now that I have this by itself, I can divide both sides by everything in the parentheses. So dividing by 1 minus x times cosine of y. So we get the derivative is sine of y divided by 1 minus x cosine of y. Okay, so other times we get equations like this. Consider the curve y squared is equal to 4 plus x, and the chord AB joining points A, negative 4, 0, and B, 0, 2 on the curve. Find the x and y coordinate of the point on the curve where the tangent line is parallel to the chord AB. So we need to think about what we have going on here. So first thing that we need to know is, when we are talking about this equation, y squared equals 4 plus x, we are looking at an equation that looks something like this. I know that because it's y squared instead of x squared, but it still is a parabola. A chord is when we have 2 points that are on some graph, in this case our parabola, that are going to be connected. Chords are a lot like secant lines. So our chord is at negative 4, so somewhere about here to here. So this right here is our chord. What we want to find is a line that's tangent, that has that same slope, but only touches our graph in this one spot. So this is what we're looking at. So the slope of the chord is going to equal the slope of the tangent line. So that's our goal. Okay. So we need to figure out the slope of our chord in order to help us out. Thankfully, this is just finding the slope between 2 points. So we have A and B. We want to find the slope of the chord. So we have B as y value is 2 minus 0 divided by 0 minus negative 4. So we have 2 over 4, which equals 1/2. So the slope that we are looking at right now is 1/2, and this also needs to be the slope of our tangent line. Well, we know the slope of our tangent line is found by taking the derivative of our function and plugging in a y value. So we know our equation, and we know what slope it needs to be. So we are going to take the slope of our, or we're going to take the derivative and set that derivative equal to 1/2 to find our y value. So finding the slope of our tangent line. So we want to take the derivative of y squared equals 4 plus x. The derivative of y squared is 2y. dy over dx. The derivative of 4 is 0, and the derivative of x is 1. So we get 2y dy over dx. I can divide both sides by 2y to get 1 over 2y. So our equation for slope is 1 over 2y. The slope that we want it to be is 1/2, so we're going to set those equal to each other. So we have 1 over 2y is equal to 1/2. Well, in order for this to be true, our y value has to equal 1. Now that we have our y value, we need to find our x value. So I know I need to find my x value because what we're trying to find is the coordinate point. So we have our y value, we just need to find our x value. So finding x. Our equation is y squared equals 4 plus x. We know what y is, so we have 1 squared equals 4 plus x. 1 squared is 1. And if we get x by itself, subtracting 4 from both sides, we get negative 3 is equal to x. So our coordinate point is negative 3, 1. This is one of those problems that looks really confusing at first, especially when you have a lot of vocab that you're not really sure about. But once we start to break it down, it's a little bit easier. This is a little bit harder than what I would expect to be on the AP test, so this is not something that I would expect you guys to be able to do on a testing situation.